Good morning students, once again I welcome you to my video lectures on signals and systems, and today I will start a new topic in Z transforms, and the Z transforms done so far referred to as two-sided Z transform, double-sided Z transform. Now from now onwards we have to deal what is known as unilateral Z transform or one-sided Z transform. One-sided or unilateral Z transform. Now compare these two. So this is what is called as two-sided Z transform. Summation n equal to minus infinity to infinity x of n z to the power of minus n. We are familiar with this form. Now second one. This is what is called as unilateral or one-sided Z transform. Given x of n, its unilateral Z transform is given by xz equal to summation n equal to 0 to infinity x of n z to the power of minus n. So if xn is given, you can find two Z transforms. One is double-sided Z transform as well as one-sided Z transform. What is the difference between these two? The difference between these two lies in the lower limit of summation. Here the summation is from minus infinity to plus infinity, whereas here the summation is from 0 to infinity. So this is the difference between unilateral Z transform and two-sided or bilateral Z transform. The difference between these two lies in the lower limit of summation. So here it is from 0 to infinity. So from now onwards, we shall deal with one-sided or unilateral Z transforms. Now we shall consider the characteristics of the unilateral Z transform one by one. Now we shall consider the characteristics of unilateral Z transform one by one. There are three characteristics, important characteristics of unilateral Z transforms. I will take up these one by one. First characteristics. Any signal x of n, 0 for n less than 0, has identical bilateral and unilateral Z transforms. Suppose you take a xn signal, and this xn signal exists for n less than 0 and for n greater than 0. Let us assume that it is 0 for n less than 0. That is n equal to minus 1, n equal to minus 2, n equal to minus 3, etc., etc., etc. Only it exists for positive values of n. Let us assume. Under this circumstance, if you find Z transform, unilateral Z transform as well as bilateral Z transform, it is identical. So any signal x of n, that is 0 for n less than 0, has identical bilateral and unilateral Z transforms. This is number one. Now I will consider the next characteristics. Now second characteristics. Unilateral Z transform is used for analyzing causal systems specified by linear constant coefficient difference equations with non-zero initial conditions. Where do we employ unilateral Z transforms? So unilateral Z transforms are used in analyzing causal systems. Causal system means right-sided systems that are specified by, described by linear constant coefficient difference equations with non-zero initial conditions. That means initial conditions are not zero. Initial conditions will have specific values. So if you have to analyze such systems, then we have to resort to what is known as unilateral Z transform. This is second characteristics. Now the third characteristics. Now given x of n, it is going to have a unique unilateral Z transforms. There cannot be two Z transforms. Unique Z transform. For a unilateral Z transform, there is no need to specify ROC. ROC, that is region of convergence, as it is always exterior of a circle. Now, as we know that x of n exists only for n greater than 0. It is a causal system for n greater than 0. So, for such xn which exists for n greater than 0, the region of convergence is always exterior to the circle. So, in the case of Z transform, unilateral Z transforms, there is no need to mention again and again what is ROC. What is ROC? ROC is always exterior of a circle. This is third characteristics. Now, these are the three characteristics for a unilateral Z transform, and in the next class I will work out problems on unilateral Z transforms. Thank you.